Good morning, good evening, dear participants. I welcome you all to session one of our ATAL FDP AI in Civil Engineering.
Is my screen visible?
Yes, sir, your screen is visible, sir. Yes, sir. Let me give the introduction, sir. Then we'll start the presentations. All right. So, dear participants, to introduce today's resource person, Professor Dr.S.Shankar, sir, who has been a great contributor in our last faculty development program as a well-wisher of our civil engineering department, PACE ITS. And sir has been a great public speaker and a great innovator too. So, throughout his career, Sir has greatest contributions and number of publications in reputed journals. And Sir has been contributing his speeches in different parts around the India and also in the world. And Sir, you have been a great contributor in our last time presentation, and we are very thankful to you, sir, that you made us feel as home because you have inspired us with your great public speaking skills and very good involvement in your speeches. Thank you so much, sir. Without further ado, I request Professor Dr.S. Shankar, sir, to start his presentation and address the gathering. Over to you, sir.
Yeah. Yeah, good evening, Naidu. Good evening. Good evening to all the participants. Am I audible?
Yes, sir, loud and clear.
Okay, right.
Yes,
Thank
sir,
you so
audible.
much. Thank you so much for confirmation. Yeah, thank you for your nice words about me. And I also thank the Pace College of Engineering Management for inviting me to deliver in a first session as part of the 6 days ATAL FDP program. That is on artificial intelligence and multidisciplinary applications. Even though we are not that background, but today the technology. So I'll try my level best, what best I can be shared, whatever the experience, a little experience I have, and whatever the research that we did at NIT Warangal, try to integrate with the technology, especially on the topic that was given to me as an innovative approaches to sustainable rural road construction in low volume roads or low traffic areas. Okay. So before I start my presentation, I just wanted to hear 1 or 2 minutes. The background or the few members can react. Of course, all civil engineer, right? All background of civil engineering or is any other branch? No. Is all the participant a background of civil engineering?
Yes, sir. Yes, sir.
Yes,
Sir. Yes, sir.
Thank you. So this is what the topic that has been given to me, and it is not moving. Yeah. So in general, I welcome you all to this first session. So my presentation outline is like this: the background of the low volume rural roads in India as well as globally. And what are the current practices that has been followed in the rural road construction and low volume road construction? Sustainable and innovative approaches that has been adapted to construct this kind of roads, and also use of the locally or green recycled materials. What is the scope? What is the technology is there? Similarly, what is the role of the technology in the today context? Followed by a summary on the discussion. So I would like to hear at least before, because it should not become a one-way movie or one-way show. I don't like it. I wanted the participant, few of you can respond by saying that what exactly, at least, what is your thought process on the topic and what are your expectations? And if you can suggest me what is exactly you are looking for, and what exactly you are benefited from this topic. I just want to hear so that I can reorient myself and it can go in a better way rather than just from the mindset. Okay, so I request the few of you please unmute yourself and you can and speak out. I hope they're unmuted themselves. They can unmute themselves.
Yes, sir, they have
Yeah.
chances to unmute themselves.
Please feel free, sir. It will be a very interactive. Don't mind otherwise. There is nothing like a lecturing. It is a two-way should be there. I request all of at least few of you, one or two of you, please guide me what your expectation from this topic. And this is the presentation outline.
Good evening. Hello, good evening, sir.
Good evening, sir. Good evening.
I'm Dr. Ravish from SDM Institute of Technology, Ujire, Dharmasthala, Karnataka.
Yes. Yeah, welcome, sir. Please.
Yeah. Sir, actually, I am interested to learn about how the AI can assist in the design as well as in the materials when you're going to use for road or maybe it is for concrete structures. So, on what basis we can choose, or what are the various AI tool we can utilize in the field of civil engineering? So that's why I joined. Even I applied for this kind of PFD.
Okay.
So even I expect AI to support like a simulation based learning as well as like data analysis for some kind of research work. Even when I'm going to offer some project to the student, at that time how I can share the AI tool. What are the actual benefits or whether it is helpful in the field of civil engineering, that I want to know, sir.
Okay. Okay. Thank you very much, sir.
Thank you.
Thank you. Thank you. I'll try to address that. Whatever the little knowledge and little experience I have in that one. Okay. Any other?
Hello,
Yeah, please.
good
Sir.
evening, sir.
Yeah,
Myself,
please.
Dr. Jayaprakash Reddy from Vishweshwaraya College of Engineering and Technology, Hyderabad.
Yes, please.
I'm looking towards how AI, uh, changes the rural road dynamics
Okay.
in this, sir. How really technology will integrate in such transportation time. Already we know that ADAS from accident monitoring, that artificial intelligence and machine learning is mostly used. How in the way of construction purposes, how AI, the role of AI will be there. I am eager. I am just waiting for that one, sir. Truly.
Okay. 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 Good. Any other, please?
Good evening, sir.
Yes, sir, please.
Sir, myself Anup Singh. I'm from Rajkot Engineering College, Sonbad, Uttar Pradesh. And sir, I think, sir, I have seen one movie of Hollywood in which there was an alien tech which scans all the buildings and points out the uh, points out the fracture points and scan it through just like X-ray, and detailed report have been generated. This type of this type of thought I have, that we can also make such type of technology which can scan through a building or any structure, and from which we can detect the failure points and other problems in the building which can happen in future.
Okay, very good, sir. Thank you. Very good, very good. So I can take one more last. Anyone, please, one more.
So we have some ideas on the chat box also, sir.
Okay, okay. I am not seeing that actually. Let me also see. Short box, I'm not able to see where it is.
Sir,
Okay,
at the
anyhow,
right. Yeah.
I'll see. Right, anyhow. Right, sir. Okay. Anyhow, that's good. So thank you very much, sir. Thank you for giving me your very valuable feedback, a valuable thought process on the lecture that we are going to deliver. Now, but let me tell you, sir, I'm not the person in the, the artificial intelligence or machine learning or deep learning or any other technology, the software technologies. But I can throw some light on the application of the artificial intelligence, the application of the machine learning, or the application of the any technology in the civil engineering. But I belongs to, especially in the transportation engineering, I'll try to address one or two issues where the artificial intelligence can be implemented or can be directly benefit or can be directly saving the cost or saving the other parameter of these things. Okay, so this is what the brief presentation of the outline. So let me also tell you where I am from. So as the organizers introduced me, so I'm Professor Shankar from NIT Warangal. This is my institute. For the NIT Warangal, you're all aware, we have around 8,000 plus students in the campus, and we offer in engineering, science and technology, also humanities department, where the Department of Civil Engineering offers undergraduate courses as well as the master's undergraduate with the intake about 120, and MTech about the 7 specializations starting from the engineering structures, construction technology, transportation, geotechnical, water, environment, and remote sensing GSM, followed by a waste management. And the department also offers a postdoctoral research fellowships. And I belongs to the research group of the Transportation Engineering Division, where we are about 7 faculty members. And NIT Warangal is the one institute in the country from the day one, the inception of the Pradhan Mantri Gram Sadak Yojana, which you're all aware, the state technical agents and principal technical agency to the Ministry of Rural Developments in the country. We have trained across the country large number of field engineers in the Panchayat Raj, in the R&B department and division also have very actually participated in the various various organization with the agencies and all those things. So for the courtesy sake, this was my department, and you all aware this Warangal. The moment you see the name of the Warangal, you remember this. You recall this a Kalathoranam, this Kakatiya dynasty. This is what the institute symbol of National Institute of Technology Warangal. Let me also just give in some slide which gives a small idea. Let me start with the presentations. We know that the Amazon is there. the Amazon is, you know, you name any 3 mm needle to the highest, even a manufactured house, you'll get on the online, you'll get from the Amazon. That's why the arrow mark is faced toward the A to Z. That is a Amazon things. Know this. You are all aware of these things. Now, can anybody tell me what exactly this is? Any idea? What is FedEx? Sir, what my request is, please let us have a one-to-one interaction, or whenever the question has to respond. It need not be correct, it need not be wrong, all those things, just for a sake of that. So courier company, I appreciate you this is. How do you know this is a courier company? Because FedEx, you might have heard about this courier company. But what I say is, as in all engineers, sir, we the engineers, we should speak the drawing, we should speak to the numbers. That is what our life as a civil engineer, right? We will speak to the drawing, we speak to the numbers. Now I must appreciate the person, the engineer or the creator who has done this a logo, because in civil engineering, I always believe our own eyes cheats us many times. Or in other words, what are the people calling today artificial intelligence, machine learning, technology transfer, or innovative, green, sustainable, all these things. It is there in front of your eyes. But how different you are, how different your student, how different your institute, how different you are in your profession is what is the point of the concern. That's what is needed. So look at this. Somebody said it's a courier company. Courier company is progressing, right? You're progressing and doing the things. Just appreciate the engineer who has beautifully inserted a arrow mark here. That is what your innovation, that is what your technology, that is what we are unique as a teacher, as a technology, all those things. So how beautifully he has inserted a arrow mark in it. That is what exactly I call to my student whenever I speak. This is what the innovation. This is what an idea. This is what that to be unique in a group of people or a group of institutions, your institution or my institutions. Similarly, we all, of course, this my generation, I have used all this technology, all this gadget into one. Now this has been olden days. It has gone now. Nobody uses it. But there is only one device which has come to in every hand is the mobile phone. You name any, either a phone, calculator, camera, or typing, whatever it may be. That is the state of the art of the technology today. Similarly, somebody asked me, sir, what is the application of the artificial intelligence in the civil engineering area? Sir, one of the application, what I feel my thought process is concerned is that, let me put you a question this way, my perspective. Sir, can anybody tell me, can whatever the technology that you wanted to use it, use it. Whatever the data that you wanted to use it, use it. No limit for you. The question is, can you predict any accident? Can we predict any accident? My question is, can we predict an accident? Yes, I definitely get somebody says yes answer, somebody says no answer, somebody yes is possible or this possible. Is it possible, sir, to predict an accident? To some extent, okay? To some extent, okay? Sir, I wanted the absolute answer, whether yes or no. Yes. Somebody said yes. I appreciate. Yes. No, sir. Yes, sir. No. Sir, then let me also put here one more question, sir. Sir, every year, when you are sitting in your office or day-to-day life, at least I could able to see the newspaper. I could hear that a Indian Meteorological Department IMD sitting in the Delhi, sitting in the Vizag, they announces a news in the month of February saying that saying that this year, June 13th evening is the monsoon is going to touch the Kerala. By June 14th evening, Telangana or Andhra Pradesh will get the monsoon. Are we hearing this one? Or are we hearing this news or not? Yes, we are hearing of this news. Sir, is he a god sitting in the IMD department or the Vizag as IMD department sitting in Delhi saying that in the month of February, March, April, May, 5 months before, 6 months before saying that, yes. Now the second part is, yes, I agree. He might be using a data which is 1,000 years old data or 1,000 years back data, maybe using your any number of a technology, any kind of a technology, any kind of a data and try to analyze. And end of the day, as an engineer, we talk about the mathematics, for that matter, any technology, it runs on the mathematics. It runs on the models. It runs on these things. Okay. So, sir, if I try to make it, yes, I also give you a data to you. A 100 years old, 100 years data pertaining to the your driver, road user, characteristics, bus, age, and everything. And I'll try to put a model in the form of, can I say a model that in the month of August 25th, a bus which is starting from the Hyderabad MGBS bus station with a speed of 50 km/h with a passenger of 50 members will reach to the NIT Warangal, and when you reach to the NIT Warangal, it will come and hit the cyclist, and that will be a fatal accident. Can you predict this? Okay, we cannot predict this. Now, if you cannot predict this, what for all these models that we are using? A mathematical called we have a linear regression, calculus, differential equation, first order equation, now the Python, coding, language, that all you're using. What exactly the output that is this test be giving if this is not given? Even I also did not find an answer today. Same thing, sir. The technology is technology. Yes, it is there. But what it is giving out is giving is also a very important question. So I said that in our conventional way, let me tell you, in a conventional, yes, sir, I agree. Sharma sir, you said answer, I agree. In conventional way, sir, we are all teachers, professors, researchers. We typically use a two kind of terminologies. One is a deterministic model. Second one is somebody saying a stochastic model. Now in deterministic model, without any technology, without any AI, without any of these things, if you have any calculator, let us assume that deterministic model means if I am having any age today, 20, 25, I'm age of 30. What is my age in 2040? Definitely I take into the consideration of the time, seconds and minute, I can make a deterministic model. So with a one single parameter, either time or age, I can, without any hesitation, I can forecast my future. That is very simple, no technology involved with that. Now, when you come to the second one, that's where the exact technology comes. Stochastic modeling. What stochastic modeling? Today, at the age of 35 or 40, Professor Shankar is a professor at NIT Warangal. Can the Shankar tell, can the student tell at this age who's studying a BTech, by the time, but by the age he gets in 40, what he would be? He would say, I'm a job holder. Which job? Do not know. Are you sure? Do not know. It means that, sir, 50% of the future prediction is a possible, but remaining 50% is an uncertainty is involved. That is where exactly the technology come into the picture. That's where you can use the technology and try to forecast what exactly happened. Okay, so move down to the further when it comes to this technology into this, especially about the rural roads. Why I'm choosing topic is that rural roads. What exactly the rural roads? Or people also called a low volume roads. What exactly the low volume roads? What exactly the rural routes? What is the difference? Why we need to talk about this kind of category of the route? Sir, we must thank all the engineers who are nation builders today in the country. I'm proudly can say that India is the second largest country today in the where we are having out of 6.32 million kilometer of road network, sir. And out of this 6.32 million kilometer of road network, I can proudly say that 80% of my road network is a rural road network. And you can see on the screen, so-called your national highway, so-called your expressway, around 1,46,195 kilometer, state highways 179, other district, other roads 60 lakhs, totally 6.32 million kilometer road network. That is what the beauty of this, because India is the villages are backbone to the country. So I was just going through before this lecture, what should I make in sense? So I was making just a survey and saying that if you try to measure, if you try to quantify what is the number that is entire face of the earth is having about the road network is concerned, that is around 33.8 million kilometer of road that exists on the face of the entire earth on this globe. That 33.8 million kilometer is equivalent to the highway circling the globe around 800 times. Highway circling the globe around 800 times. That is the kind of a network. Now, sir, you're all aware, those who are involved in the research and construction. I'm sure that today in the country, the average cost of the rural road cost is around not less than anywhere in any state. Take it as granted from any state, it is not less than 100 lakhs, 1 crore. Average kilometer of the cost. If you try to look at the scenario for the same, a national highway, 4-laning, average kilometer cost not where anywhere between the 18 to 25 crores. Such a amount of money has been poured into the highway sector. That's good. I agree. But the question here is, sir, why this is when the PMGSY started, I myself was involved in the 2000 to 2013, 2013 to 2020, 2020 to 2025. Let me tell you the figure, sir. The figure is in 2000 to 2013, the average cost of the rural road was, it was around 30 to 35 lakhs. After 2013 to 2018 to 18 or 20, it's gone to around the 60 to 65 lakhs. Today is 100 lakhs. I'll tell you why I'm just telling this number. This okay. This one side of these things. So what exactly these roles, the rural roads? Rural roads plays a very important vital role in the economic development, culture development, educational, recreational, day-to-day life of the rural communities heavily depend upon this. But unfortunately, a researcher or a policymakers like you and me, we see that low volume roads are very less important roads because these roads are not going to create any kind of a revenue for you because these are for the purpose of connectivity, not for the purpose of revenue generation. That's why people will see a very less important of the road. But in the villages, the farmer must find some way to transport an agricultural product from the village road to the local road. Definitely, a rural road play a lot of economics, lot of technology, lot of these things. That is what the background of the rural roads. Now, if I ask you, some of you, just for your quick understanding, what is a rural road? If I ask you to draw in a hard line between the rural road and high volume roads or low volume road and high volume road, so take it as granted from me. There is no hard bound definition that exists on this planet as the rural road, low volume road is concerned. The question is this: across the globe, 75% of the researchers, technology provider, or the states, or devotees, or departments adopt 75% of the this about saying that 400 vehicles per day is called as a very low volume rural road. The reason for adopting a low volume rural road is that if you are in the rural background, try to make yourself. There is a study, there is scientific proof saying that during the peak hour low volume rural road. The peak hour low volume rural road is about the 15% of your daily traffic of urban traffic. So 15% of your urban traffic of 400 is about the 60 vehicles per hour. If you try to further translate, it says that 1 vehicle per minute. Sir, I guarantee you, please go back and see in the village areas. Are we really getting 60 vehicles per hour? Are we really getting 1 vehicle per minute? No. But what we are trying to do is that it is mostly a non-motorized traffic. Okay. Why do you want to waste the resources? Having in a 1 meter crust of the pavement section, high quality material, those things. I'll come to that part. So this is what exactly so there is no exact definition that is available on this planet. When you come to the Indian definition currently says that a road which carries up to a 2 million standard axle is termed as a low volume rural road. Okay, that's what the background of the rural road. So there is universally there is no accepted definition for this. Even the American Association of State Transport Officials also given this kind of a definition for this. So many of us might have said the same. I enjoyed this road. I am enjoying now this kind of road, and the people, the entire country is enjoying this kind of road today. So friends, sir, what I want to say is that if at all is there anything that in the civil engineering in transportation area in the Indian history, if it has written within a golden words, I proudly announce that before the millennium, after the millennium. What is after before after million means 1947 to the 2000 year. There were no design guidelines, no construction procedures. Even if at all there, they are based upon the ad hocism, high judgment of the engineers, under the experience of the engineers. There were no sound guiding principles are available. Thanks to the technology, thanks to the then Prime Minister of the country, Atal Bihari Vajpayee, who was a great visionary who taught this. And today, my rural India, is enjoying this kind of a road of these things. That is the beauty of this rural road today in the country. And you can see the women's and men transport basically what happens to non-motorized traffic mostly in the rural area. And not only that, this is the picture that gives the South Asian rural scenery on the most of the rural road. This is what the state of the art and the technology that we are having today. Right, sir? This is the one side of the coin. Now see the second side of the coin. I said 100 lakhs per kilometer, 100 lakhs per unit kilometer. And there is a great saying, if at all you want to know what is your soil properties, put your head in the mud. Similarly here, just throwing the amount of money into the mud. These are my pictures I have taken in the entire country I have traveled, and these are the condition of the roads. These are the condition of and all these roads are hardly 1 year, 1.5 year, 2 year, or maximum of less than 5 years. Now, what is the problem? What technology can be adopted here? What AI can be used here? What green material can be used here? What is the reason? Whom to blame? Engineer, society, contractor, quality, department? What is there are n number of numerous reasons. There's a different issue. I'll not come upon that one. Okay. So this is what the things. So how can we find out? How can we try to give him a scope for this? So this is what exactly now as I was telling, this is a picture of the rural road PMGSY in the country. This is a self-explanatory slide. I'll share this PPT to you. You can go through this. But this is the a transformation that has been happened in the country from the 2002 2025 today. I'm happy to say that PMJ4 also is started in the country today. Now, sir, let me ask you a question here. Yeah, since I need to talk about the technology, I need to talk about the sustainability. I also need to talk about the artificial intelligence things. I'm slowly coming up one by one. I'm trying to, please bear with me. You will be ending up it. Now, sir, this is a study done by me, my student in 2013, as I told to you. So you can see this picture. You can see this picture. In the year of 2005 to 2013, and 2005 to 2013, the first picture is average cost of the rural roads with and without cross drainage structures. With and without the cross drainage structures. Sir, from the Warangal, the Khammam is around 125 kilometer. From the Warangal, Karimnagar is around the 75 kilometer. Warangal is center. Within the span of radius of 150 kilometer, if you try to see the average cost of the kilometer, in a Khammam district in 2006, the average cost of the kilometer is 15 lakhs. This 15 lakhs gone to the 2008, 24. And the Khammam, by the time you come to the 2013, it has gone to the 88 lakhs. Same thing in the Warangal, 55 lakhs, Karimnagar, 66 lakhs. Look at this, without CD works. This is the with CD work, without CD works. It comes to the 47, 67, 54. And today, 2025, this is 100 lakhs. Sir, why I'm telling you this? Let me put you one question. I'm sure that all of you might have an answer to this question, might not have an answer to this question. Sir, is there any substitute for a water on this planet? Is there any substitute for water? Yes. No. Absolutely no, sir. Absolutely no. I agree. Now, sir, why I'm asking this question is, sir, this part or this part, money is okay, sir. You having a money is fine, but the required materials, the payment materials, the entire planet, the entire globe is facing the crunch of the material today. Sir, how long? How long you keep on excavating and exploiting the natural resources? The day will come. The day will come definitely. I think I have read somewhere 1.5 years back in one of the Hindu papers saying that one of the quotation, the rate at which we are trying to exploit the natural resources currently. Listen very carefully. The rate at which we are trying to exploit the natural resource currently, if this trend continues, in next 250 years, entire planet can be blown up. I am sure, sir, the day will come. The day will come. I'm also expecting down the line of next 30 or 50 years, if at all the war comes between the state to state or country to country, nation to nation, wife and husband or neighbor to neighbor, it is not because of something else, sir. It is only to get the pure drinking water. Whatever you earn, your part of your salary, you need to be spent only for drinking water. Now, in that aspect, what I'm trying to, in that aspect, now entire planet, every agency in the country, every agency globally, they were trying to find out the solutions for alternative material, alternative technologies. These alternative technologies are in the form of calling a green material, in the form of a sustainable material, in the form of a marginal material, in the form of a new material, innovative, etc., etc., etc. Somebody was telling, sir, robo sand. Yes, sir, I agree. I agree. Sand is available. Stones also available. That's what I'm telling. This is the one side of the story. Now, other side of the story is that country like India is abundantly blessed with a lot of innovative, locally available, marginal, sustainable material. But unfortunately, we are not using it. We are not exploiting. We are not making it of the making of such resources. As a result, this material is simply lying in the environment, causing a serious environmental pollution. But there is a move now. There is a move now. That's what your technology come into the picture. Why? Why the engineers, those who are working in the field, or policy makers, what made them not to use this technology? Why they are not exploring it? There are different ways and means, concerns and problems are there. I'll not touch upon that things, but right now, these are the kind of the technologies that is available to you. I don't say lime or a cement or a bitumen, these are the new technologies. I don't consider it as a new technology. This is there from the ancient Roman civilization, Mesopotamia, those things, cement, but now we are calling a cement and a lime, bitumen. I don't consider them as a new technologies or a new things. These are old materials. But thanks to the academia, policymakers, researchers like you people who have contributed in the form of a guidelines or a technology that is available today. But in some states, the locally available material like a brick aggregates, blast furnace slag, steel slag, zinc slag, rises, bag ash, quarry waste material, fly ash, RCA, RAP, GGBS, many materials are there which are also simply lying. Now it is the technology that you can use and try to find out, try to reduce the cost. That's what we are talking about, the sustainability point of view. I'll come a little bit on what is the sustainability. And these are the technologies that with and without the, these are without the, with the IRC code of practices, these are the without the code of practices, these things. Okay. Now, what is to be done for this kind of things? So one of the sustainable solution in the civil engineering is people are talking today is the geosynthetics. Geosynthetics. I don't know how many of you are working on it. Things, sir. Geosynthetics are the class of the material today that is available. At least for the rural road point of view, this technology is working better. This technology definitely can be improve the life of the pavement and is cost effective, environmentally sustainable. So we know that the movement to talk about the sustainability stands on the three pillars. One is environment, two is economic, third one is, any idea? It is in a social. Now the fourth one is also one of my PhD student at NIT Warangal. We are working out the fourth parameter also called today materials. So all these four pillars, environment, economic, social, and materials, this is what we call as a sustainability materials. Now, these geosynthetics are going to help us in, you can see this kind of because rural roads are the roads which are very, very, very interior. Very interior. I cannot have any costliest technology. I cannot construct a 1 meter crust. I cannot use any higher quality materials. I cannot put any more money on this. But as this material is concerned, this is performing. So this is one of the technology that can be definitely used in the low volume rural roads. Where can be used? Yeah, these are the, we are all known, those are the civil engineering, different functions, different part, different application that can be used. But sir, look at this here. Within the, if you talk about this reinforcement, this technology as a separation technology, as a reinforcement technology, as a fencing, erosion control, lining, drainage, and asphalt layers. This is the kind of things. But if you look at the road wise, sector wise, erosion, drainage, but where my road construction occupies about the 44% of the total these things. That means it has got a huge potential, the kind of a material, the kind of a technology that is there in the country today. And you can comfortably use this technology for the construction of these roads. Suppose imagine that you have any construction without any geosynthetic material there, because we all know that India is predominantly blessed with your BC soil or your expansive soils. And we all know that these soils behave very erratically in summer and winter. We have to got any process in swelling and shrinkage properties. In order to counter, in order to these things, let us see how this is my classical pyramid cross section. Okay, so I can, if I use it without any kind of a things, if I'll try to move a loading part on this is what my likely failure chances of my payment structure. So in order to counteract this, I can use a reinforcement, I can use a separation function, I can use a different functions. So if I allow the further to move this is what the scenario that is going to be happen. You can see further. Now, if you can try to put some kind of a type of a tensor geogrid, you can try to put these things as a reinforcement area at the top of this upgrade. Now you can see the load distribution, thereby you can extend the life of this payment, life of this category of the road. Of course, I don't say that geosynthetics need to be used on the low volume road. No, it can also be used in the high volume road, but the life cycle cost is concerned, the cost, the economics are concerned, they are much performing better on the low volume rural roads. And this is what exactly with the geogrid, your payment is going to be function. And this is what the different statistics or different criteria that we are interested when you talk about your payment design, which is going to reduce your sigma V, epsilon V, and is going to be increase your sigma H, and is going to be your vertical, compressive, horizontal stress and strains on the top of the subgrade. And as a result, this payment is performing the better things. Okay, so this is the one technology that can be used very comfortably in the rural road method of things. Now, let me also say, we don't, I don't only the technology just to tell you, but at NIT Warangal, we also do a lot of work on this. Sir, we know that today anything that you talk, it's not that only a laboratory part. Laboratory is only simply a simulation, but the real life conditions or the real field conditions are entirely different. So what we are trying to do is that we have constructed an APT, which is called an accelerated payment testing facility. This accelerated payment facility technology is that you can see here, we have divided it into several portions. So each portion is some X, Y, Z, P, Q, means of different geosynthetics material. You can see this coir mat has been anchored properly, and we have done these things, and we have run. When we have run for a 1 lakh, 2 lakh, 3 lakh, 4 lakh, 5 lakh, 6 lakh, 8 lakh, 9, over a month and 2 months and 3 months, and try to evaluate what is this technology, how it is working. So end of the day, the output from those technologies that you can see, if I have a conventional payment without a geotextile, my total thickness will be around the 480 mm for the rural roads. There is no saving. If you adopt adapted thickness with woven coir mats, the total means 480 is adapted. So this is a 350, there is a saving of 130. If you have a coir composite, you have a saving of another. Total thickness is this, you have a saving of 111. If you are applying a combination of geogrid and non-woven coir mat, and your total payment thickness is 373, you have a saving, you have a reduction in the saving of sub-base material in the terms of 107 mm thickness of material subness has been reduced. So this evidence is that yes, this kind of technology materials definitely going to be extend, improve the life of the pavement of the rural roads. Now, as I said to you, this is the technology. Sir, why need for a new technologies? Why we need a new technologies? Why you need a new technologies? As I told you, this is very precious on this planet. Sir, I have seen it myself to share with you with the august body. 5 years back, I was traveling in the state of Telangana at a district called Adilabad, which is a border of the Maharashtra and Warangal. A 8-year pregnant woman, 8 years pregnant woman, walking through the forest area, carrying in a bucket, going for a 1 bucket of dirty water to survive their life. It is in a mid-May. Just imagine their life. Second thing, look at this ILAC, sir. Where I stay NIT Warangal, from NIT Warangal, my native place are 150 and 30 kilometers, 2.5 hours drive. This is the ILAC which I have seen in my childhood. Look at the height of the ILAC. Unfortunately, today, from the ground level, it has gone to this much of deep into the ground in the name of the development. Second thing, look at this. So what I want to say is that natural material is a diminishing, become a scarcity. Even that is available, they are becoming a costliest. We need to find out an alternative for this way. That's what we need in new technologies. Now, look at these roads. Very beautiful road, state highway that has been maintained, very ugly maintained or very badly deteriorated pavement of the rural roads. I appreciate this one, but I cannot appreciate this. What is the reason here? Forget about the technical part, design failure, these things. What is the reason? What is the failure mechanism, or why this has happened just within after a less than 1 year? Can I do something here? Can I do something with the technology? That is worth it. Now in that background, since the natural materials are diminishing, available materials scarcity. Now everybody, you might have aware that full depth reclamation is the technology, is the need of the hour that the people are talking in the country. I hope if somebody from Uttar Pradesh, where currently NIT Warangal is doing a research, there are about the 5,000 kilometer of road that has been constructed in the state of Uttar Pradesh. These roads are under evaluation for different monsoon seasons. Now, FDR technology is one of the such promising technology where why I'm telling is 2000 year to 2025, 25 years of PMJSY is over. The roads which are constructed from the 2000 to 2005, now probably the phase 1, phase 2, phase 3 roads might have been come to the very, very, very bad shape. That is what I said, 80% of the network is in a very bad shape. Now we need to revamp this. So again, you cannot go for the natural material, not available. Even if it is available, too much of cost. That's what an exact word. Full depth reclamation, the name itself you can. If you have an existing damaged road like this, you need not to bring any fresh virgin material from any sources. It is only make use of the existing material, make pulverizing the existing material, add some kind of a cement, add kind of some stabilizer, add some kind of a dosage, and bring the required equivalent strength of your WMM or your WBM. Sir, whenever you go to the field, usually the field engineers have any doubt, have any question. Professor Shankar, you are a professor and you are an academician. You can come to you'll come to the field and you say this technology working, that technology working, this technology good, these things. But one peculiar question that I get every time is that, let us assume that this is what my 150 millimeter of my WBM or my WMM. And you know that there is no substitute for the natural material. Okay, if I use a 150 millimeter of this, my life was comfortable, my road was serving better, my road was performing better. I did not get any show cause notice, I did not get any of these things. Now you are coming and telling that with the use of the new technology, with the use of the new material, with the use of green material, 150 mm can be reduced to the 100 mm or 75 mm. Such kind of technologies you are telling this. What is the guarantee? Even if you give the guarantee, where is the code of practice? Where is the standard schedule of rates? Where is the quality control criteria? Where is the performance criteria? This is the main hurdle in the country today. But thanks to the technology again, sir, like academicians like you and me, research agencies, technology provider, anything, today, I can confidently say that there is a reasonably sound and justified technology, knowledge, guidelines, procedures are available to adopt the new technologies. The Honorable Minister was telling the Minister of Road Transport and Highway Ethics, we need to abolish the cement and steel. What is the alternative? Tell me. That's what the question, that kind of a things. So FDR is a one such kind of a technology where definitely we can make use of the economics and the life of the payment these things. Okay, so this is a cost effective, sustainable, fastest way of rehabilitation of the roads with a 100% reuse of the existing pavement material without using any new material from any quarry, any resources. So that much of hauling distance, that much of material can be saved comfortably. That's whatever FDR technology, these things. There is also one more, which you are all aware, self-filled concrete block pavement technology. So this technology originally developed in South Africa. Later on, Professor B.B. Pandey from IIT Kharagpur was transferred to the Regencies and finally also adopted by the National Rural Road Development Agency in the country. You can see, especially in the West Bengal, in the Uttar Pradesh, and some part of the north, and some of the part in Hyderabad, this technology has been used based upon using your self-filled concrete payments. So this is developed based upon the numerous laboratory on-site materials, but the beauty, the success of this technology depend upon the size, shape, and the orientation of this kind of a self-filled payments. This is what the another new technology that can be implemented these things. Now let me come back again. I asked you, sir, is there any substitute for water? You said no. Sir, is there any substitute for aggregates? Yes, it is there. Sir, is there any substitute for a what do you call soil? Substitute soil means, is there any agent? Is there any way that we can make the soil so sound, especially the block butted soil, especially the expansive soil? Yes, we can. Yes, we can. Many of them tell, yes, we can. Yes, sir. This is the another kind of a sustainable technology or a new technology. At NIT Warangal, I myself was involved in this kind of. So you can see in the market, today, to the best of my knowledge, there are about 146, 136, what do you call, Indian Road Congress accredited materials are available. Indian Road Congress accredited materials are available. These accredited materials, among one such of material is the This is called a terrazil soil stabilization. So you can see here, sir, in NIT Warangal campus, we are trying to experiment on it and try to improve the subgrade of a block cotton soil. And whatever the soil that we have collected, the soaked CBR of the soil was this. Soaked CBR of 1% and unsoaked CBR was about 5%. Okay. And so this technology provider came to NIT Warangal saying that, sir, if you use my technology, this is going to be given a 100% CBR. I am very 200% CBR, 500% CBR. Sir, I'm very afraid of even getting a 100% CBR. It become like a rock. You know that it become too brittle, it cracked. I'm worried. But don't believe such kind of things. But what I did is, I have made a systematic study. What the systematic study is, you can see that I have taken a one sample with the treated, one sample without treatment. When I'm trying to make it in a soak in the water, it is simply collapsed. Okay, it is simply, this is the math, simply collapsed. Then what I asked my student, okay, this is the laboratory study. What you can do is, but before that I did a one study. What I did one study is that I have taken a lump of the block cotton soil. I have pulverized it. I made it like laddu. I have some water and I have put some 10 ml or 15 ml of drop of this. And I tried to make a laddu. And I made a laddu. I just made this sample into the glass of water and I have soaked it for 16 days. I have soaked it for 16 days. After soaking for 16 days, I have taken it out. And I was trying to do that, how we do in our house, like a custard apple, whether it's ripen or not. We will try to, we will put like this. I'm trying to do this. It is bouncing back to me. I took a hammer and I started hitting it. I started hammer and started hitting it. After hitting 1, 2, 3, 4, 5, 16, I could find that after a small crack has been formed. Now, what beauty I wanted to say that most of that what we are feeling is that whenever we encounter such a problematic expansive soil, technology is available today to treat this material. You can ask me, sir, this is there from the long day. You can use a cement, lime, all those things. I'm not denying, sir. But when you try to the cost point of view, this is much cheaper, and this is going to be a very promising kind of a performance of the payment. Then we have taken a real time of one test, simply a test track, and constructed a subgrade. And to the best of, happy to say that we got it even after a 2 days soaking the subgrade. I got an ever at some doses. I got a nil permeability. No water has been get into the subgrade. So this is the kind of a technology or chemical or material, alternative material that is available today in the market. Definitely we can make use of it. It is not only that, we have done, a government of Andhra Pradesh has done one study. They adopted this kind of a performance evaluation of using this terrazine, other kind of a technology where these things, and these are the roads that they are constructed. All this road we have evaluated in terms of their functional, in terms of their structural, in terms of their riding quality, they are performing well. So I can say that based upon the roughness, Benkelman deflection rating survey, observed that the terrazine sections in Nellore and similar to that the performance of control sections, road observed to be very good in condition. In terms of the performance, in terms of the measurement of rating, they are equally performing to the control section, means with the natural materials. Why can't we use this? Definitely, this is one of the promising and different technology. Now, let me also tell you the other third one technology that is new innovated. We all know that we use an RCA, we use an RAP. What is RAP? RAP is reclaimed asphalt pavement. RCA is recycled concrete aggregate. Sir, for the life of the building, 100 years. National highway, designed for 20 years, a rural door designed for 10 years, exposure designed for 10 number of years, a 10 number of years, something like that. We have a different period. Now, after the 15 years of the 10 years, whatever so damaged road, what you are going to do? Everybody, including you and me, has gotten a opinion that it is always better to construct a new pavement rather than repairing or improving or rehabilitating existing pavement with a new technology. No, I myself involved with, you can see here, recycled concrete aggregate NIT Warangal is established in 1959. We have got a main building which has gotten repair or modification. We got in a 2004. So all this material, lot of recycled concrete gate C&D, construction and demolition waste material has been lying in the campus. We were trying to make a research on this. So you can see here, sir, RCA, recycled concrete gate percentage, 0%, 25%, 50%, 75%, 100%. We are trying to replace it, these things. Water absorption up to the 50% is no issue. But Indian Code of Practice says that it should be less than 2%. Okay, but when you're trying to improve the percentage of these things, you can see it is not meeting the criteria of water absorption. 100% is going much beyond. It's a maximum 2%. But thanks to the again technology today, we have a sophisticated method and technology to treat this material. The reason for such kind of numbers, a reason is this is already served for so many number of years. So it has othered by a motor content. That motor content is observing more water absorption. Hence, it is giving a beyond certain limits. It's not satisfying the criteria. So we have also done studies using this mixed type and try to study the performance. If you are using in the bituminous roads, what will happen? This is what the picture. We can see that 50% wrap can be used if you are using in a 7.57, 7.5, not 7 mm of rutting. Control to the 50% wrap 24.2, control mixer 16.2. So that evidence says there is a lot of potential use of this sustainable construction technologies, construction materials in the use of the rural roads or in the case of the high volume roads or in the low volume roads. Now, technologies. Sir, is there anyone in this, anybody of your a design process, design thinking, any research project, any kind of a bridge have you seen in the India constructing within such a huge load within a wooden bridge? No. To the best of my knowledge, no. Mostly it is no. But you can see simple treated. This is a wooden log, and see in the rural area the bridge serving the purpose. You can also say this just on the rural road, the two-wheeler drive. Of course, this need to be properly taken care, but you can give in thought process of it. But this also. Now you have to tell me this. What is your comment on this? This is one of the recent picture that I have taken during my visit. Whom to give a show cause notice or whom to address this? I do not know. I do not know. This is disturbing me. And especially on the rural roads and in the things, we never see this kind of a planning perspective. Elsewhere, this is not my pick, excuse me. This is taken from one of the professors from the US who was working in the forest department. Shared me, why don't you adopt an Indian system like this? This is one of the means, very simple, very known fact only, but we are not implementing. So with this, sir, let me before going to the what is the trends to the 2050? Let me also tell you, somebody asked me the initial, sir, I wanted to know the artificial intelligence or machine learning or this technology can be used. This. Sir, currently, I'm not using the full technology, but currently I'm working on one project. That project exists. AI, ML, AI and artificial intelligence and machine learning based, evidence based traffic data collection for the design of rural roads in Indian context. So I will tell you what exactly your artificial and also we're also working with the right now with the ministry. Recently, we have also MOE'd one project where your involvement of your artificial intelligence and whatever. What is the first project? Let me tell the second project is. Suppose this is my road. You have a number of trucks and traffics on this road is traveling. Okay. This is the way. Now, what exactly the AI or ML technology now is? If you use your AI, which has already been developed an ML kind of an algorithms, it will give the 17 analytics. 17 analytics. What are those analytics? You need to have your camera, dashboard, connect to your mobile or connect to your computer system. You travel at an 80 km per hour or 100 km per hour. Let any number of kind of vehicle on the traffic stream. You are using your AI camera, using your AI algorithm, it captures the every vehicle nameplate. The moment it captures the nameplate, the analytics that you get is you'll get the speed of the vehicle, you'll get the number of the vehicle. Based upon the number of the vehicle, it will go and try to find in your interface with the ministry or state or a different website network, and it will give you whether your vehicle has got a vehicle what you call pollution control, whether your vehicle has got an insurance, whether vehicle has how many times your vehicle has got a violation of the rules, how many times your vehicle has got an accident involvement, is your vehicle. So like this, all kind of 17 kind of analytics can be easily captured without any hesitation, without any manpower. If the technology is not there, just imagine how conventionally we were trying to capture this kind of data. So that is the one potential area in the transportation engineering, sir, and the transporting. And second thing, somebody was telling that how the AI or ML or technology. We at NIT Warangal, you know that NIT Warangal is now the 60 or 65 years old. We have a department of civil engineering. We have a ground G+2 floors building over there. So we have a proposal that we need to construct one more floor on the top of it. So we thought that how to do this, unless you know the details of the reinforcement, unless you know the details of bars and all those things, you cannot. We have approached to the market. We have a technology today like a laser-based technology. You just need to put the laser to the column and beam. It will give the entire number, bars, diameter, and you can try to find out the things. Okay, that's it. And the third most important, where I am working right now, sir, in the country, as I told you, from the 2000 year to 2013, all our field engineers, the great nation building engineers, they were very, very, very systematically doing their job. Without hesitation, I can tell. But at the same time, they have taken a small lenience. From the 2013 or 2015 onwards, I can say, people started doing a reverse engineering. People started doing a reverse engineering. So what is reverse engineering? Suppose we are all aware as a civil engineers that I wanted to design a road When you design a road, you should have two fundamental parameters. One is traffic, another is soil properties. Traffic is the most important things. So we know that we need to get any traffic data. So till the 2000 year, every engineer systematically go to the rural area, sit on the road, conduct a 3 days traffic volume, peak out traffic volume, ADT, find out how many commercial vehicles, how many non-motor commercial, everything is happening. But later on, when technology came, this has gone in a things. So yeah, because I'm ST and PTA, when I scrutinize the DPR, when I asked the engineer, sir, I have a doubt on this DPR. You brought to the curve of T9 traffic curve. I don't think this area will have any T9 curve. Then we start argumenting. I have gotten a provision that if the ST and PTA wanted to test it, I can go there, I can conduct a 1 hour, 1 day, 2 day, 3 day traffic, I can get it. Then the engineer comes and say that, sir, we'll do one thing, sir. Via media balance, via media solution is, you please take it as a T6. Then this is also wrong. I don't accept it. How can you say simply like that? Then what should be there? So in this case, recently, I have talked to the ministry and come to the one of the AI or ML application is that what we are trying to do is, sir, what I did is, suppose, let us say, this is X, this is Y. This is a one habitation, this is a second habitation. Okay. I know that this is in a 500 population. I know this is in a 1500 population. I have any connectivity. Another scenario, habitation P and Q. I have gotten a 50 population, I have gotten a 150 population. I have any connectivity. I got a third scenario, 25 population, 50 population. Now, where your AI, ML, also called your deep learning, your artificial intelligence, your artificial neural network, all this technology we can be used. What I'm trying to do is, I will try to conduct a survey here and there. The survey may be a primary data, maybe a secondary data for one time. I also need to get what is the land use, land cover, consumption of petrol, consumption of diesel, how many educational schools, how many primary schools, how many high schools, all this data I try to get it. Okay, now thereby, now this road is costing 100 lakhs. Why? Because engineer has brought within a T6. But I wanted to minimize this, or I wanted to make an exact prediction of the traffic depths. So I can make in such a way, like your y is equal a naught x1 plus a1 x plus dash 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 an xn, all we are aware about your a linear regression model, dependent variable, independent variable, coefficient of all these things. We can train using artificial. X is traffic. This traffic is having a 1, 2, 3, 4, this n number of inputs. These n number of inputs, again, you have gotten something strictly speaking, input layers, output layers, and finally, you have gotten a one output. So starting from these two, input layer and output layer, this entire process, we are calling it as a deep learning. And you can train the parameters, you can train everything, and you can try to get, when the engineers comes to you, you don't talk to him. You just say that, yes, what is your state? My state is Telangana. What is your mandal? My mandal is so and so. What is your village? Villages. What is the population? what is the population, what is the land cover, what are these things. Enter it and show him that you cannot have a traffic more than T2, you cannot have a traffic more than T7. This is what evidence-based data. This is what the technology can definitely help us in using your ANN or using your artificial or anything. This is what we can try to benefit this. This is what I can say that where I'm trying to use this technology right now. And if you try to with this, I just try to make this trends to the 2050. 2050, what are the trends? What are the trends? Just a minute. World population currently the 6,600,000,000 crores in 2000, and it is estimated to be 6 billion in 2050. Imagine how much road network, how much food, material, what the kind of things. So definitely we need to think of this new alternative. So they just says that one of the study, but FHWA continued growth in rural roads of 1 to 2 million kilometers per decade between now and 2050. Food needs of 9 billion world population. Next surge in rural road building is similar to the US and Chinese experience century, expect to occur in the Southern African well before the 2050. In other parts of the world, primary focus will be on the improving rural road capacity and quality of the cater to the expected 3 to 4 increase in the passenger and freight transport between the 2000 to 2050. And finally, the profile mobility motorization in China and India. In the next 10 years, China aims to provide all-weather road and connectivity to 75,000 administrative villages, and India to more than 1 lakh rural habitation in the country. So, if in order to make these things, we have a bigger role. We have a bigger role of the technology. Bigger of these things can be comfortably used. So, my last slide would be those things. I don't know why it is moving. Yeah. So, sir, to summarize my lecture in terms of the technology, in terms of the ethics, in terms of the social responsibility, in terms of the sustainability, I always show this PPT to my student whenever I speak to the class. So what exactly the example mean? What are the real indicator of success of low volume roads? So if I'm trying to give you that, I have in my black box technology. I'm trying to give in a 1 kilometer of the road. Okay. And also I'm trying to give you other parameters as an input to the technology. So this was my success path, or this is my outputs to the society, to the individual, to the nation, to the village, to the technology, to the growth. So what are the expected that you can have from this? What are the output that you can expect from this? Can you tell? 1 or 2? Yes, sir. Let me show you. Mostly the solution or output will be in the form of time, in the form of a cost, in the form of education, in the form of environment, in the form of a trade, health, jobs, and profits. Now, I feel all these are at your individual level, or society level, or a selfish level. But my rural roads, they're a real indicator of success in the country. Overall, any government, any nation, which were trying from the day of their existence to till today for a one single cause, that one single cause is nothing but your poverty reduction. That is the poverty reductions. So with this thought, I conclude my lecture saying that if you want to save a person, be a doctor. If you want to save the world, become a civil engineer, because the greatest creator next to the God is civil engineer. So thank you very much for patiently listening to me. I don't know whether I have given justice to my topic or not, but whatever the little experience that I have in using this, I shared with you. Thank you all. So I'll be open for if you have any questions.
Thank you, sir. Thank you for such a valuable session. Now I request participants, if you have any queries, you can unmute yourself. You can ask the queries to our resource person.
I hope I have not made you bored. Yeah, somebody was asking which AI tool is most appropriate for design of the road. Sir, to the best of my knowledge, as of now in India, there is nothing like in a tool that has yet come to replace our conventional pavement design or a road design. But in terms of your so-called your geometrics and or three roads or Bentley, MX, after all this has been upgraded, but for the road design, yet maybe in the near future, maybe soon, it may come out. But to the best of my knowledge, in India as of now, we don't have any such kind of a tool that is readily available, which can give you a design part. But people are talking deep, what do you call chat GPT, deep, deep sake or something, etc. If you give something, it will give you. But I also strongly believe computer doesn't have any brain, sir. You and me, the engineer, has to give us some logic, and we must find out the solution optimally. It will give you. We can make use of a faster calculation or decision making, but hope in future definitely that also may be replaced. We do not know, but I'm not fully aware which kind of a tool or a technology that is currently available in India AI is concerned. DeepSeek. Thank you, Anuj.
Yes.
Sir, I have a one general question to the concluding marks I wanted to all the August audience. Organizer, can I take 5 minutes?
Yes, sir.
Sir, forget about this lecture. But as a professors or the academicians, we are all, at least I don't say we are all, at least myself, having about the 18 years experience of teaching in these things. What is missing today whether in the name of the technology or in the name of the ethics in the professional life is truth is missing, sir. Truth is missing. So can anybody tell me what is the truth that you can say? Truth means, sir, it's not the form of the synonymous, it's not form of the abbreviation, it's not form of these things. In the student community or in general in the education system, I always ask my questions, students, I ask, what is this? This is a pen. I ask with this hand, what is this? This is a pen. Go out of my room and ask someone, what is this? This is a pen. Go to the Hyderabad and ask someone, what is this? This is a pen. So what is happening here is, sir, truth is the one which will not change with the time, with the location, with the individual. If that is changing, that cannot be called as a truth. Unfortunately, you name any technology, I strongly believe any replacement, everything, there is no substitute for the teacher in the classroom. Similarly, there is no substitute for the conventional system or philosophical system that we are established and using in the education sector. That's what I wanted to just. So I just want to conclude with that one. So I once again thank you. Thank you for all of you giving me this opportunity to share with you the little knowledge that what you have. Thank you all. Yeah, please you can take over.
Yes, sir.
Nayagaru.
Yes, yes. Thank you, sir. Thank you for that delivering a great session, sir. And talking about the sustainability and importance of sustainable road construction and giving practical examples and the work you have made on behalf of organizers, faculty members, and participants of this FDP. I sincerely thank you for making the time to share your knowledge and expertise with us. The lecture has not only enriched our understanding, but also inspired us to explore and adopt sustainable practice in our teaching. Sir, you have been a great inspiration from the first FDP, sir. I hope you remember all of us. And you have been a great support till that day.
Thank you. Thank you. Thank you very much.
Thank you, sir. Thank you for delivering such a great session. And with this,
Sir, if you have somebody have any questions, I'm just making my email in the chat.
Yes, sir.
ss@nitw.ac.in. You can email me, or you can also WhatsApp me on 9849102935, which are shared in the chat box. So thank you all. Have a pleasant evening.
thank you, sir. Thank you so much. And dear participants, as our second resource person of today's session, Dr. K.K. Sangle sir, is already in the meeting. Let me give a brief introduction about sir, and then I'll hand over the session to sir. So it gives me immense pleasure to introduce our esteemed guest, Professor K.K. Sangle, Dean Academics and Head Structural Engineering Department, VJIT. Professor Sangle is distinguished academician and researcher in structural engineering with expertise in earthwork engineering, structural dynamics, and steel concrete structures. He published extensively, guided many scholars, and many significant contribution in civil engineering education. For his exceptional dedication to teaching and academic leadership, he was honored with Ministry of Education's National Award to Teachers 2023 by the Honorable President of India. Professor Sangle is not only an accomplished researcher, but also inspiring mentor, whose work has left a lasting impact on both students and faculty. We are privileged to have him us today. With great respect, I invite Professor K.K. Sangle to address the gathering. Sir, over to you, sir. Thank you.
So good evening, sir. Are you able to hear me?
Yes, sir.
Are
Yes,
you
sir,
able
we
to
can
hear
hear
me?
you, sir. Loud and clear. Sir.
Thank you. So thank you, Professor, about my introduction. Are you able to see the screen?
Yes, sir. Yes, sir.
Yes, sir. It is visible, sir.
Is it a full screen or small screen? Just- So good evening to all, and thank you host for introductions. My general topic is on what are the application of artificial intelligence in future in civil engineering. What are the probable areas where artificial intelligence can be used, and which will give you the brief idea about the sectors areas where we can use it effectively. Let me clear, I am not a computer guy. I am a structural engineering professor, and I am just have predicted. So what are the different applications? And I will give the very small brief about artificial intelligence and then how it can be effectively used in the different areas of the civil engineering. So artificial intelligence is the simulations, most of us knows that, of human intelligence processed by machines, especially computer systems, enabling them to learn, reason, and make the decisions. So this is what brief AI. So different components comes under the AI are deep learning, neural networks, natural language processing, computer vision, cognitive computing, and machine learning. So computer students study all these things. We cannot become expert in this because we are a civil engineering, but for us these are the tools. And people, we have to, as a structural engineer, as a civil engineer, we can take the help of the computer expert and we can predict the outcome, or we can decide the outcome which civil engineer want. So small brief on this, how this works. Deep learning means what? Deep learning is a subset of machine learning that uses artificial neural networks with many layers, hence it is called as a deep, to automatically learn complex patterns and representation from large amount of data. So this is very short definition of deep learning and machine learning. So if you go in detail, you will find key characteristics. Most of us, most of the civil engineering professor are working neural networks. I have seen several papers by civil engineering professors, those who have used neural networks for their research. So these are the key characteristics of the deep learning, that is neural networks, future learnings, large data and computing needs, end-to-end learnings. In machine learning is the core modern AI. It gives computers the ability to learn, predict, and adapt from the data, forming the foundation for deep learning and other AI advancement. See, in all AI techniques, what we require extensive data, and that we have to learn the machines through the data. Computer vision is the eye of AI, giving machines the ability to see, interpret, and act based on the visual data. Internet of Things is also terms used in the AI, so which connects the AI with smart device and sensors. Many times, if we do in structural health monitorings, so we require a lot of sensors and devices to gather the real-time data. So that comes under the Internet of Things. Then predictive analytics use current and historical data to forecast events. Applications are maintenance, scheduling, traffic pattern predictions, demand forecastings, and which reduces the downtime and improves the network management. There is another tools required for AI is the robotics and automations. AI-driven robots improves logistic and supply chains. So you must have seen automated guided vehicles, drones. So that comes under the robotics and automations. This is the brief about natural language process and cognitive computing. So with this brief about AI, so let us see our main application of AI in civil engineering. So those faculty members who are interested application of AI in civil engineering, so they should read at least basic books on AI, so to understand how it works. Anyhow, we cannot become expert in AI immediately, but at least we should have some certain basic knowledge how AI works and how we can give the inputs, civil engineering inputs, and how we can expect the outcomes from the AI. So if you see, almost every area of the civil engineering is very soon covered by the artificial intelligence. So it may be structural engineering, transportation engineering, geotechnical engineering, water roads engineering, construction management, urban planning and smart city planning, building information modeling, and environmental engineering. So I have given a brief about all these 8 areas, how this AI can be used in future. So first, my topic is that artificial intelligence in structural engineering. What we can do in structural engineering by using AI, we can do the structural health monitoring. We can predict the loads and structural. We can do the structural optimizations. Present softwares are not doing a structural optimization. Present softwares are giving you the design based on the input which you have given. Present softwares are also not predict the load path. So then we can use this AI for earthquake and disaster resilience. We can use for construction process automations. We can use it to the integration with the BIM software. Digital twins for structural systems that AI can cover. And in long run, sustainability and energy efficiency also this AI will cover. So you people must be aware about that structural health monitoring. So what structural health monitoring basically? So we require sensors to collect the data or to acquire the data. There are different type of the sensors available to collect the data, depending upon which type of the performance you want to monitor on the structures. So that type of the sensor you have to use or you have to attach physically to the structures which you want to do the structural health monitoring. So there will be the data acquisition system and role of the computer that AI will start once you get the sufficient data through the sensor. So then AI will process the data as per the requirement given by the civil engineering and give the outcome or output in the form of what civil engineer or structural engineer expect. So this is what structural health monitoring work. Right now, presently, what we do in structural health monitoring, we are not continuously monitoring the health of the structures. We do structural audits, we take a photographs, we do the non-destructive testing and all these things. But actual performance, because of the actual live loads or actual vehicle loads or actual any type of the loads, we are not measuring continuously. So very soon those structures are critical or we call as a important structure for the nations, so for which importance factors we generally give the higher than as compared to the other normal structures. So very soon these structures we have to monitor for their structural health, and the different type of the sensors and all this will come into the picture. So this is also one of the growing field. And in structural health monitoring, AI will be used very extensively. So this is one of the area. Very soon AI will cover it with different type of the sensor, different type of the data acquisition system, high-end computers processing the data and then giving the results and all these things. Even if people are developing the apps for that, so the decision makers message will receive to the decision makers. So what type of the decision they have to take? So through their mobile handset or through the apps which has been developed for this. So as I told you, structural health monitoring involves the continuous observation of infrastructure such as bridge, buildings and towers to assess its integrity. And AI enhanced structural health monitoring offers early detection of anomalies, means if there is any cracks, corrosion, fatigue in the structures. So we can, that AI can predict it. Real-time insight through the automated analysis. So every times we don't need to go to the site, take a visual observations or anything. So this data will come to us. Then preemptive maintenance we can is leading to the improved safety and reduced cost. So based on that output, so we can do the maintenance and we can improve the safety and further reduce the cost. So this is the schematic, what you can say, the process flow of monitoring the structural health monitoring. So since different type of the sensor are there, including strain gauges, so that collect the data, then that data goes to the data management system. That data will be analyzed by the computer by using the different techniques what I have briefed earlier. and then it will give the report to us as a civil engineer. So these are some real structural health monitoring things which I have shown on the screen. People are using nowadays. People are using for bridges. There are some case studies also which we have used at here. Generally, structural health monitoring is actually a costlier. Means it's not what you can say very cheap. So first thing is that sensors are costlier. Then you require continuous monitoring systems. So therefore it is used only in large infrastructure projects and which are critical projects. So generally for long span bridges. So these are the some real structures on which structural health monitoring are going on. So this is what I have listed: long span bridges and high rise buildings, rail infrastructures, airport terminal and runways. So these are the what few examples where presently people are using structural health monitoring. So these are what brief about how the structural health monitoring of that each structure has done. So one of the example I have taken is the Shanghai Tower, China. So purpose of that structural health monitoring was ensure safety during construction and service life, provide real-time data for maintenance and finite element model updates. Structural health monitoring system components are there. Objective was to monitoring main stations as well as total 11 substations were there. So different type of the sensors are used to measure the wind velocity, displacement, stress strain, temperature, corrosion, cracks, and seismic responses. And measurement tools are used for precision level gauges, hanging steel tape, vibrating wire sensors. So this help them to analyze and optimize this tower effectively, and depending upon the during the construction stage also, so they collected several informations and that they have upgraded into their further analysis and design. So this is the what you can say some sketches. This is we have taken from the paper which has been published in International Journal of High Rise Building. Another application of the AI is the load prediction and optimization of the structures. So AI-based load prediction and optimization refers to the use of machine learning algorithms, neural networks, and optimization techniques to forecast how loads, basically dead, live, wind, seismic, and thermal, are distributed in the structures, and to determine the most efficient design parameters to minimize the material uses while maintaining safety and performance standards. Right now, at present, what softwares are there that are not defining different load path or alternative load path. Many times we require that alternative load path also if some certain structural elements fail in case of the, let us say, because of any reason, then which are the different alternative load paths are available. So that has to be known to us as a structural engineers. So we will be able to design good structures if you know the different type of the load path. So traditional load calculation rely on assumption and static models. AI can adapt to real world conditions using large data sets, and which support the performance based design and sustainable construction goals. Enable predictive safety checks before actual construction or during operations. And key area of application: bridges, high rise, stadiums, offshore platforms. Even if in this can be used for retrofitting and strengthening of existing structures where we want to do the optimizations. I just want to give the more trust on the performance based design. At present, if you see in Mumbai, basically in Mumbai area, there is one committee which is called the expert review panel. There is no code present at present in the buildings having a height more than 250 meters. And at present, there are 25 buildings in the Mumbai which is having a height more than the 250 meters, and maximum height what we have recently analyzed is a 310-meter height of the buildings. If these buildings are called as a code exceeding buildings, means at present there is no Indian code available for analysis and design of this type of the structures. Now, what mandate is given to committee is that if there is a code exceeding building and no codes are available, then we have to do the performance based design. Even if in tall structure code also talk about the performance based design. And at present, very few softwares and few expertise is available in India to do the performance based design correctly. So the software which are performance based designs is in development stage. Few softwares are available, but not giving the very precise or accurate results. So very soon, AI technology will be used for such a type of the softwares. There is a disturbance from, I think, somebody's mic is on. So this is the how the AI enables load prediction and optimizations. It collect the data, then use the artificial intelligence and machine learning techniques and give the output to us. So sensor data plus historical data, AI models, different type of the AI models are available. Then it forecast the loads and give us the optimized design. So this is the what you can say the general flowchart through which you can understand how my AI can be used for load prediction and optimization. So there are certain real examples or people are doing the research on that. So international load seismic load optimization of high-rise building in Tokyo. Then another example is in India, AI-based load prediction for Mumbai Metro elevated sections. There we have used this load prediction and optimization. Bridges at present, Golden Gate Bridge in USA. Another application of the AI is that damage detection in for structural health monitoring. So for damage detection using AI, we require a CV and DL approach. That is a so damage detection in structural health monitoring is the process of identifying, localizing, and quantifying the structural defects such as cracks, corrosions, or fatigue, using automated AI-based system for timely maintenance and prevention of the failure. So key technologies, computer visions that I have briefed you. What is the computer visions? Deep learning. Generally in computer vision uses image processing techniques to interpret and analyze the structural image or video data. So if you have images of the structures, or if your input is in form of the images or videos, and then you can extract the or you can identify the different type of the damages happening to the structures, or even if you can identify the cracks or corrosions or fatigues from the image only, photographs or videos. And drones and all these can be used for the taking photographs or taking the videos. If that photographs or videos are given as an input to the computer, then computer vision will process it and give us the result or give us the outcome in the form of crack, corrosion, and fatigue. Okay, obviously it required a lot of knowledge of the structural engineering to predict the defects, structural defects from the images and videos. So another tools technology you can use as a deep learning, so which uses advanced neural network to automatically learn features and patterns from large database for accurate defect classifications. So at present, myself and one computer professor are working togetherly on image processing. Problem is from the civil engineering, that is a structural engineering, and student is from computer engineering. Topic is that that same topic we have taken is that can we predict the structural defects from the photographs or pictures what we have, and this we have, you can say that photographs in crores form, because from last 20-25 years we are doing lot of structural audits, so we have sufficient amount of the data with us in the form of photographs, and now we become a successful at the level is that now this student is able to segregate the photographs in the different categories. So that is, it is a dampness, it is a cracks, it is a corrosion, something like that. So we have classified the different type of the defects, and accordingly the photographs are segregated. The second level that we have then reached is that we have identified the length of the crack, width of the cracks, type of the cracks, whether it is its inclinations. So it again segregate the photographs depending upon the length of the cracks, width of the cracks, inclination of the cracks. Then slowly we are reaching to the point that from the 2D photographs, that is, if you know the width and length, can we predict the depth of the cracks also? So that machine learning, we are providing the, what you can say, the data to the computer in this form. So there are several photographs we have provided to the computer as input, which having known length, known thickness, and even if in known depth. So can it learn and can it predict the, for other photographs, the depth of the cracks? So if we succeed into that, so that will be so great research outcome for us. So that is what we can use computer vision and deep learning to process the image for the detection of the damages. There are wide applications, as I told you, bridge, tunnels, dams, high-rise building, aircraft runways, detecting cracks. So these are the things. Image processing, you can say that. Computer vision in damage detection, that already I have briefed you. So this is the, what you can say, how it works. So deep learning also, briefly I have informed you that how the deep learning works. So these are the way through which you can detect the cracks for the structures, and what this is the, what you can say, the flow which happen in the structure. So we can take a real photograph through the drone, then we can give it as a data to the computer, then through the neural network or different type of the computer techniques, it process that data, then it develops certain model deployment is there, and then we get the prediction also. So different type of the same things we can get at here with dimensions also, whatever length is there, whatever width is there, which type of the crack is there, we can then structurally classify these cracks. So these are certain photographs which has been taken. So then another thing is another techniques, which is digital twins in structural system. So digital twin in structural engineering is a dynamic virtual replica of physical structures, like a bridge or building, that uses real-time sensor data and simulation model to monitor performance, predict behavior, and optimize maintenance through the structural life cycle. So core component is a physical structure equipped with the sensor. Means we physically install the sensor on the physical structures. Then we virtually model the things that built using BIM or finite element analysis. Then we integrate the data, that is real-time updating of the virtual model. And we use AI analytics tools to find out the anomaly detection, forecasting, and decision making. So these are also one of the growing area in the structural system. The application, basically digital twins application in structural system. So this is about how the digital twins works in the structural health modeling. So model creation, sensor integration and data collection, model updates, analytics, and decision support. So this is a 4-step. So digital twins work in structural health monitoring. So these are some graphical forms of the working of the digital twins in structural health monitoring. So these are the some. This is a model created of real structures. Then for railway bridges, for few live bridges, it has been used. These are some papers, what case studies are there for application of the digital twins in the structural health monitoring. These are the real case studies. People are doing a research on this also. This is the outcome of the results, finite element modeling, and you can predict certain data. Then another application of the artificial, this is about structural engineering. Structural engineering also having huge application of the artificial intelligence. Some of the application in transportation engineering. I'm not a transportation guy, but still we have the what research materials available on open sources from which we have collected this data, and people are working on this different aspect of the application of AI in transportation system, particularly autonomous vehicle, traffic management, predictive maintenance, public transport optimization, smart tolling, safety and surveillance. So these are the different application of the AI people are using in the transportation systems. Most of us know about the autonomous vehicle, that AI in traffic management. So self-driving cars using AI to navigate roads, interpret signals, and make real-time decision without human input. So in that also the AI technologies are used, the deep learning, computer vision, neural networks, reinforcement learning, and convolutional neural networks. So these are the different type of the techniques people use in the autonomous vehicle. So there are certain benefits of the autonomous vehicle. So this is the workflow of the autonomous vehicle, how the autonomous vehicle work, which has been presented. The workflow of that is presented at here. This is what you can say in workflow. So these are the some case studies about this. First autonomous vehicle is launched in 2018. Then expanded in the San Francisco, Los Angeles, and Austin. So these are the real photographs of the autonomous vehicle. So this is the how it works, that autonomous vehicle. So advantage of that autonomous vehicle, it has more safety, zero at fault accident in millions of autonomous miles driven. So accessibility is there, reduced human error are there, and scalability is there. Environmental benefits is also there for what you can say the in autonomous vehicle. So now autonomous vehicles are very common nowadays. Even if in India, that autonomous vehicle has entered. The traffic prediction also you can do through the AI by using AI technologies. So to anticipate congestion, accidents, or delay before they happen. So it enables us to proactive traffic management like adjusting signals, rerouting, or sending alerts to the drivers. So these are the things used in the traffic prediction, that AI tools, different type of the tools are there. So this is just representative photographs. So how it will work, that also has been mentioned here. So data collection, model training, prediction, and action. So these are again case studies of automated traffic surveillance and control. So few case studies are available. Search it on the net also. So generally in traffic management it is extensively used. So you must have seen in the expressways, highways, there are the cameras. So they monitor the speed of the vehicle. So if you cross the certain speed, immediately the data will get processed and you will get the message that your fine is this much, like that. Even if you see the FASTag and all this, these are nothing but the AI driven all tools and everything are used in India also. So even if in AI that detects the accidents, also breakdowns, wrong way driving, or unusual traffic event in real time. See, if you see many times in our country, there is a traffic jam because many people not following the traffic rules, and there is no continuous watch on the people. Means many times it is mentioned that heavy vehicles should go from the left side, but they can come on the right side also. So right lane means right side means right lane. So AI powered cameras are there, so they can predict that heavy vehicles are coming on the rightmost lane. Then immediately fine can be given, or even if in message can be sent to the owner or driver. So you are not followed the rules and all these things. So nowadays these technologies are used in the expressway, freeways in our country. Yamuna Express Highway, this is the case study that how this automated incident detection systems is used in our country at Yamuna Express Highway. So Yamuna Express is the expressway is 165-kilometer high-speed corridor between Greater Noida and Agra, and AI-based automated incident detection systems introduced to improve the safety. And the key technology used are video incident detection system, automatic number plate recognition, CCTV every 5 kilometers, and AI powered analytics. So this is used in Yamuna Expressway. These are the photographs of Yamuna Expressway. So this is written that how it works and benefits. So cameras capture live traffic footage across the expressway. AI algorithm detect incidents in real time. Control center receives instant alerts. Patrol vehicles and emergency teams are dispatched. So VMS board inform other drivers to slow down or take cautions. Each alarm system issues fines for violations. So AI can be used in the public transport also. So these are the certain applications of the AI in public transport. The role of AI will be their optimization operations, improve service reliability, and enhance passengers' experience in urban transport networks. So another application of the AI is in public transport. So smart fare collection, you can collect the fares by using the computer technology. Passenger safety and security you can achieve through the AI-based surveillance system in station, buses, and trains. So this is what pictorial form it is presented. So AI adoptions at New Delhi railway stations. So there is a New Delhi railway stations. AI tools are used for this in public transport. So in February 2025, so this you know that there are 18 deaths due to the overcrowding, and hence that AI was adopted there. So these are the AI-based measure introduced there. AI-driven crowd monitoring, CCTV plus AI to detect overcrowding in real time. Centralized war room, 32 major stations including NDLS monitored remotely. Permanent holding zones. color-coded waiting areas to control passenger flow, and facial recognition systems identify threats and habitual offenders instantly. So this is at New Delhi. It is in working condition now. So this is the workflow chart. You can use AI in RT geotechnical engineering also. That we discussed about structural engineering, transportation engineering. You can see in the what type of the applications are there for AI in geotechnics. So again, if you see, these are the what basic things about AI. So traditional geotechnical challenges are inherent geological uncertainties, complex ground conditions, limited data and observational methods, and highly variable soil properties. These are the present challenges are present in the geotechnical engineering. These challenges can be overcome partly or completely by using the AI tools. So machine learning for soil classification. So you can use the machine learning for soil classification. So key findings will be leveraging artificial neural networks and support vector machines. These are the terms which generally computer people are aware about this. And what you have to focus that we should get the idea what this can be done, what can be done by using this machine learning and these things. So impact will be that so this innovation will transform traditional geotechnical site investigation, enabling significantly faster, more consistent, and highly cost-effective soil characterization. So if you map the soils or soil results or soil data, bore log data of any particular areas, so you don't need to carry out the soil investigation again and again. You can classify the soils by using the machine learnings. So these are few research papers available on this classification of soil by using machine learning. So prediction of geotechnical parameters also can be done by using AI. So in test that if you have a in situ test CPT, SPT, and PMT results, so that you can give as input. So you can find out through the machine learning models. So you can
Hello.
predict the geotechnical parameters also. So these are again another research paper. So they have predicted the geotechnical parameters by using the machine learning tools, AI applications basically. There are several research paper. Our research is going on that many civil engineering people are using this AI tool. So this AI can be used for slope stability analysis also. So there are few papers available on that also. So how we can do the slope stability analysis by doing AI. So this is the impact of by using AI for slope stability. So you can use a tool for risk assessment also, geotechnical risk assessment. Generally, if you see there are landslides and all these things happening, so this AI can be used for that. That is risk assessment. These are some research paper on it. So again, another application is that AI for tunneling and underground structures. So which mostly are not visible easily. So where we can use the AI for monitoring these structures. So there are few research papers available for on this topic also. There are certain challenges in this AI, but right now we will not discuss that. Slowly, as the result or application increases, so that challenges will be overcome. Then another application of the artificial intelligence is the water resource engineering. So why we require AI in water resource engineering? Because we require improved forecasting, efficient water use, real-time monitoring, data management, and disaster response. Generally, for these things, we require AI in water resource engineering. So in irrigations, we can optimize water use through the smart systems. Optimization enhance the efficiency in water distribution and treatment. So these are the different areas of the water resource engineering where you can use the AI. So water distribution system, river basin management, groundwater management, irrigation and agriculture, water demand and consumption, flood management, water quality and wastewater treatment, water drainage system, hydropower and marine energy, water retaining structures. So there are large applications of this AI and machine learning in the water resource engineering. These are the certain roles, how we can enhance the hydrological modeling, improving the disaster preparedness and water quality monitoring through the AI. Agriculture applications. So this is what about water management. You can do the better management of the water by using the AI tools. So the key application of the AI in water management are water demand forecasting, flood and drought predictions, irrigation and agriculture, and water quality monitoring. So you can use AI tools for these four things. So you can see how this artificial intelligence can be used. These photographs indicate that to what you can say the complexity of the problem. So these are few research paper on which people are working. These are what you can say the emerging technologies integrated for future smart water management systems. So you can identify the soil moisture by using AI and IoT based tools. So these are the what you can see in the photographs how it can be identified. So this is one of the research paper for smart irrigation. Then another use of the artificial intelligence in construction management. So few example are that you can predict the project delays, you can optimizing labor and material uses, you can detect the safety hazards before accident happens during the construction process. So that's this is the reason why we require AI in construction. So present traditional challenges in construction management, they are poor scheduling accuracy, resource wastage, limited risk prediction, insufficient communication, and low productivity. So all these you can overcome by using the AI tools. There are certain benefits if you use the AI tools in the construction. that is improved efficiency, your efficiency will get improved. Then there will be the cost savings, you will get the enhanced safeties, and better decision making system. So these are the what flow chart. It will brief us, give us the idea how it works. So this is one of the research paper we find that AI powered modular housing in NSW Australia. You see, there was a challenge and how they overcome the challenge by using the AI solutions. So they use the mobile micro factories powered by AI. AI managed fabrication of walls, frames, service cores, and foundations, and QR coded components plus AI optimized logistic for on-time assembly. So see how effectively these people have used the AI in modular housing and in prefabrication particularly. By using AI, you can uh, predict the results as well as delay. You can prevent the delays also. So these are the advantage what results they got. So these are another application that optimizing scheduling and risk management in construction project by using machine learning. So these are the different tools used in the AI. So other AI application in construction are AI in quality control, detecting defects via image recognition, AI in safety monitoring, real-time site monitoring with drones and cameras, and AI for sustainability. So you can optimizing material use and energy efficiency. So these are certain challenges in AI adoptions. There will be the challenges, and there are the challenge also. So for example, high implementation cost, training and expertise requirement, data availability and quality issues, integration with existing system, change management resistance, and cyber security and data privacy risk. But whatever challenges are there, that will be overcome in the due course of time. At present, people feel that there are challenges, but you know that technology is changing very fastly. People adopt the new technology very fastly. So there may not be in future alternative other than to use this technology. These are certain future trends in AI for construction. That robotics in construction, definitely very soon robotics will come. You must have seen the 3D printing structure constructed by using the 3D printing. So digital twins will be used in the construction. Advanced predictive analytical tools will be used. AI will be integrated in the construction or almost every field of the civil engineering, and fully automated project management. So your number of people will get reduced. It will be fully automated. Artificial intelligence can be used in urban planning and smart cities also for development of proper, what you can say, the planning of the cities and making the cities more smart. So these are the what exactly the smart city is. So generally it is having a sustainable infrastructure. It must have ICT integration, smart mobility, and safety and security. If all these four cases are there, four things are there in place, so we can say that this city is a smart cities. So sustainable infrastructure, ICT integration, smart mobility, safety and security, and everywhere you can use the AI tools. All these four areas you can use the AI tools. So these are the application that urban growth prediction, land use optimization, traffic and mobility planning, environmental impact assessment, disaster risk mapping, smart resource allocations. These are the application of AI in urban planning. Benefits are that what faster planning, data driven decisions, sustainability will be there. So GIS, most of the people are aware about the GIS. So GI is nothing but the one of the AI tool actually. So land use mapping, zoning, infrastructure planning, environmental analysis, urban growth monitoring that are done through the GIS. So there are limitation of traditional GIS that will be overcome by using the AI tools. There is a term Geo AI. Geospatial artificial intelligence is the integration of artificial intelligence, geographic information system, and big data to analyze, interpret, and predict spatial patterns. It leverages machine learning and deep learning algorithm to process massive geospatial data sets, enabling faster and more accurate decision making in the field like urban planning, environmental monitoring, transportation, and disaster management. So these Geo AI tools will be very soon. It will be available. So you can see that cycle how it works. So there will be the machine learning model used in Geo AI. These are urban planning related. AI can be used for the energy efficient infrastructures also. It can predict the energy demand, optimizing building design, smart grids, automated energy management, retrofit recommendations, urban heat island mitigations, water energy nexus optimization. So all these can be identified, and energy can be this, energy efficient structures can be infrastructure can be created by using AI. These are the some applications. So AI application in building energy management, that are another applications, or even if in electrical and mechanical people are using it. These are certain papers on that. So you people are aware about that building information modeling software, the future of constructions. So building beam, nowadays people are more focusing on the beam also, application of the beams. And now beam is upgrading by using AI tools. So it has enhanced beam and design optimization are there. So, and I think what I understand very shortly, people will use only one software for all civil engineering is the beam. So these are the certain introduction of beam. It is a building information modeling system. So if you see the areas which is covered in the beam, so almost it cover all civil engineering field. So this I will not talk more on the beam. So you can use the what you can say the AI for quantity estimation also. So if you see traditional method is a manual takeoffs from 2D drawings, slow and inaccurate. AI driven methods, AI extract the quantities directly from beam models, that is concrete, steel. At present also beam model give us the quantity approximately. The different tools you must have seen, Revate is the one of the software we use, AI plugins. These are the different softwares available in civil engineering also. These are the benefits of that software. 30% faster estimates, reduce human errors, linked to the cost database for real-time tasks. So quantity estimation also you can do by using AI driven or AI tools. So another application of AI is the construction sequencing also. You can identify the construction sequence. These are the applications in the beams, what you can do. So another application is that material selections. So AI tools you can use for the selection of the material. So the material which is a smarter, sustainable and cost effective. Even if you can identify the material which is a climate adaptive. You can do the concrete mix design also, this concrete mix optimization by using AI driven. There are a lot of research people are doing on concrete mix design by using the AI tools and supply chain optimizations. So structural system optimizations that also right now what we do in the software, we create a structural system, but very soon that software will itself create a structural system. Right now we have to give this as input to the softwares, but if you use the AI tools effectively, so from the AutoCAD plan directly you will get the design. Software will decide the optimum structural systems for that particular plan if you give the heights and all these things. So then very soon software will be able to identify the proper structural system with optimizations. So you don't need to give the define the structural system, column size, beam size, slab thicknesses. So that will be automatically taken. You just give the input as a architectural plan. So it will decide everything. Right now it is not available, but very soon you can see this type of the software also where AI tools are used. So there are application of the AI in environmental engineering also. So just we will have some certain brief applications. So you can, by using a AI application tools, you can have a climate change modeling, flood prediction and mitigations, air quality monitoring, waste management optimization, and water quality. This can be used in the environmental engineering. So these are the what you can say the applications of AI in environmental engineering. You can predict the flood by using AI tools. So air quality monitoring. So these are the papers. These are certain case studies, which is that papers are available on the Google. So for waste management also you can use the AI tools. So in solid waste management also you can use. So now if you see in conclusion, almost AI is reshaping environmental engineering, not only environmental engineering, but if you see every field of the civil engineering, every areas of civil engineering where AI will be used. Just for information of audience, if we are most of us are from the academic background, and I just brief you the latest initiative of the AICT. So AICT has constituted one committee by framing the curriculum of first year and second year. In future, maybe in future, first year and second year curriculum for all branches will be common, and along with your basic science subject, engineering subject, few courses will come in that, but every branch, that application of AI in civil engineering, application of AI in mechanical engineering, application of AI in production engineering, any branch of basic engineering. So there is a huge application of artificial intelligence. So now, henceforth in academic also going to change, though the main fundamental will not change, but applications, we have to teach the application of the artificial intelligence in particular branch. So that already people have started thinking on that. AICT has started thinking on that. At least 40% curriculum of civil engineering will come from the computer engineering. How we can use all these tools effectively in the civil engineering. Now, civil engineering will not be only pure civil engineering branch. So we have to study certain basic courses from the computer engineering also, which are related to the artificial intelligence. Maybe it is introductory, but civil engineer shall have the knowledge of certain basics of the artificial intelligence. So my objective of today's lecture to give you the brief idea how these AI tools will cover the use in the civil engineering, and what are the probable applications of this artificial intelligence in civil engineering, and how the civil engineering will change in long run. So this is what all from my side.
Thank you, sir. Thank you for the valuable presentation. And to notify to the all participants, Dr. K.K. Sangle, sir, has been chaired ACT model curriculum and has made involvement of some computer sciences courses as well as AI courses in the curriculum, which were already recommended. Okay. Now I request all the participants, those who have queries, can can ask their queries with the sir, as the sir is open to queries now.
There is one message. What are the books for understanding about AI? Actually, you can. There are so many books available online also. Fundamental of AI and all these things. You can read any books. It is not particularly for civil engineering. Right now, there is no books particularly available that is like application of AI in civil engineering. What the data I have collected, all data I have collected through the research paper, ongoing research at different professors are doing jointly along with the computer engineering professors. So there is no specific book available at present for only civil engineering, application of AI in civil engineering.
Hello, sir.
Yes, sir.
Sir, my voice is audible, sir.
Yes, yes.
Yeah, sir. Good evening, sir. Sir, myself, I'm Viresh. So, have you mentioning that AI tools we are using in environmental engineering, specifically about waste management and quality assessment, right?
Yeah.
Sir, is there any specific tool which I can use for knowing what is the water quality index? So, which can helpful
See,
for
let
me?
me clear one thing is that
Yes, sir.
I am a structural engineering professor. I have just collected the data in other field. But if you ask me questions about structural engineering, I will be able to give it correctly. Environmental
Okay.
engineering, just this is the information I have gathered from the open
No,
research.
no, actually, my background is environmental. That's why I'm asking.
Yeah, no,
Actually,
that's why
if I
I'm
can use
clearing
any
that.
tool, yes, sir, which can increase the novelty of my paper, na? It is helpful for me to get published.
That
So
you
that's
have to do the literature review on that. So the people from the environmental background are using the AI.
yes, sir. Yes, sir. Okay, thank you, sir.
Thank you. So can you end the lectures post?
अगदी पिकलेले पण तरी पण ती अगदी असं
Yes,
So,
sir.
thank you
Let-
for giving me the opportunity to talk and express my views about application of AI in civil engineering. My just suggestion is that for all the professors or all the participation is that participant, as Professor Shankar is also told, basic will not change in civil engineering, but when we were the student, we were not aware about the any software, design software. We used to do the moment distribution methods, Carnage methods, and all this method to analyze and design the structures. Now, if you see the height of the structures increased from, let us say, 10 meter or 15 meter to the 300 meter in India itself. So then how it is difficult to analyze, design the such a type of the buildings or structures. So our structures are also changing. So we have to change along with the time, and we cannot remain aloof from the application of the computer or softwares or AI driven tools in civil engineering. If you want to be good civil engineer or excellent civil engineer, or if you want to be expert in future, then you have to learn these things. You cannot run away from learning these AI tools applications. So that's what I want to conclude.
Thank you, sir. On behalf of organizers, faculty members, and participants of today's FDP, I extend our heartfelt thanks to you for sharing your expertise. Your lecture has not only enhanced our knowledge, but also motivated us to think innovatively and apply these technologies in our own teaching, research, and professional practice. Thank you so much for your great informative session, sir. And we are very happy that you, such a uh, great person, is available with us on this session today. Thank you so much for being with us, sir.
Thank you and good night to all.
Right, sir.